So, shh, we're quiet now, please. Yes, Eric. What do you need? Yeah, I said yes, Eric.
No.
What is your question?
No,
because
I haven't taken it.
What?
Yeah, there's 3 people that haven't taken it yet.
I'm guessing it's her too, huh?
Yeah,
Yeah.
and Tyson.
And I.
See, I have had to like test for so many of my classes.
Okay, well,
I'm not even
we're gonna do this. So today we're going to design a binomial experiment.
Oh my goodness.
So we're going to use the following guidelines when conducting these. So we have 4 steps. First step is to describe a trial for the situation and determine the number of trials to be conducted. Step 2 is to define a success and calculate the theoretical probabilities of success and failure. So we do need to state what is a success, what is a failure, and state the probability of each. Step 3 is to describe the random variable x, which we've done before. And step 4 is to design and conduct a simulation to determine the experimental probability. So we're actually going to conduct this experiment. So a binomial experiment can be conducted to compare experimental and theoretical probabilities. So our example. We want to conduct a binomial experiment to determine the probability of drawing an even numbered card from a deck of cards. Then compare the experimental and theoretical probabilities of the experiment. We're going to use a random number generator to create a simulation of 52 trials. Okay, so we're going to outline each of these steps. So step 1. Okay, we want to describe the trial. Okay, step 1, we want to describe the trial. So what would our trial be given this situation? What is the trial?
I think it's.
What are we doing in this?
Seeing what the probability is of drawing an uneven number card.
Okay, so our trial is drawing a card.
Where's the I?
Okay, so our trial is drawing a card from the deck. Okay, the second part to step 1 is to determine the number of trials to be conducted. Well, I wrote that in your problem itself. So, the simulation will consist, of 52 trials. Yes, you shouldn't write super big on this. Will consist. Okay, so we did step 1. We described the trial, it's picking a card from the deck, and then how many trials are going to be conducted. That's 52. So then we need step 2. So we have to define a success and calculate the theoretical probabilities. So what is a success in this situation? What do we want to happen?
Even numbered card.
We want an even numbered card. So success is drawing an even numbered card. Okay, next we need the probability of success. Okay, so you need to think about a deck of cards and how many even numbered cards are in that deck. Okay, so there's 52 cards in a deck. No, not counting the jokers.
They're not even. I'm talking about the deck itself.
Okay, so you have 4 2s, 4 4s, 4 6s, 8s, 10s, jacks. Okay, so
I really like it. I like you curled it. I see it.
I did curl it.
Tegan,
So
you have a girlfriend.
you have 24 even cards in your deck. So success would be 24 out of 52. Okay, there are 24 even numbered cards out of 52. Okay, and I'm just going to reduce that fraction to 6 over 13. I counted the queens as even, as 12. Because it would be number 12.
What? Doesn't count. Does not count.
Yep. Okay, so that's the probability of success. Probability of failure. Okay, failure would be picking an odd numbered card. Okay, so that your probability again has to equal 1. So if my probability of success is 6 over 13, my probability of failure would have to be 7 over 13. Okay, because when I add those together, it should equal 1. Okay, and if you want to, you can write that as a decimal instead of a fraction. Okay, so if you took 6 divided by 13, wrote it as a decimal, that would be fine too. Okay, so do you understand where I got the 7 out of 13 from?
No, isn't there supposed to be more even than odd?
No, aces are odd. And then
but
kings are odd.
Kings are odd? I thought they were equal to 10.
No, I just went every other for the face cards. All right, so we finished up step 2, so now I want to go to step 3. Step 3 is to describe the random variable x. Okay, so the random variable x represents what?
X represents even numbers.
The even numbered cards. Okay, so the number of even numbered cards drawn. Okay, so your random variable x represents the number of even cards that you drew. Okay, so that was step 3. Last step we need is step 4. Okay, step 4 is to design and conduct a simulation to determine the experimental probability. So we are going to use a random number.
How many steps are there?
4 generator. Okay, I need to, since I'm using a random number generator, I need to state what each number represents, since I do have face cards and I have an ace in my deck. So we're going to let 1 represent an ace. Okay, so we're using 1 for an ace. Okay, let 2 to 10. Shh, pay attention, please. Let 2 through 10 represent card value.
It's the last one.
Well, we actually have to conduct the experiment. And then let 11 to 13 represent the face cards. Okay, so we are going to conduct this binomial experiment. So I am going to create this table here. Okay. I'm going to need to make my table bigger.
Any more space besides like for this?
Just a small space at the bottom. All right, so I have 2 different outcomes, my success and my failure. What is my success?
6 over 13.
That's the probability, right? But what is a success? It's an even numbered card. So I need an even card. And then my failure is an odd card. Okay, so those are my 2 outcomes. And I'm going to use the random number generator that was listed at the top there in your problem. Okay, I know you're still copying. I'm going to go back. Just give me a moment. At this website right here, okay, you can get a list of random numbers to generate. Okay, I'm going to do it on mine for now, but for your homework, you will need to go to this site.
Do that on the test too.
No. I'll give you the random numbers. All right, are you good with copying down what I have so far?
Yes, ma'am.
Don't crinkle things. All right, so this is what that site looks like. So you need to first, okay, put in how many random numbers to generate. That's your trial. So how many trials do we have? 52. Okay, we have 52 trials that we need. Okay, each integer should have a value between 1 and what? 13. Okay, there are 13 because I used 11 to 13 as the face cards. Okay, and format, you can put it in however many columns you want. It doesn't matter. I'll just leave it at 5. Okay, and then you just have to press get numbers. Okay, so you just have to enter the information that we talked about in those first 4 steps there. Okay, and you end up with these random numbers. So in your tally section, you need to tally how many even numbers there are. Okay, so this is our experiment. So we're drawing a card. So our first even number here would be 12. So I have 12. I have 4, so I can make 2 tallies from that first row in the even card section. So in your table, put 2 tally marks in the even card section. Then I have 10 and 12, so another 2 tallies. Okay, then our next row here, we have a 10 and a 6, so again, 2 more. So we should have 6 tallies so far. Then we have 1 here, 2, and 3 for that row. So 3 more. And then 12, 2, and 4. So again, 3 more tallies from that row. Okay, this row I only have 1. Are you making tallies as I go here?
You're
So 1, 2 in this row. So 2 more tallies. Should have 15 at this point. Okay, then we have 1 from that row, so 1 more. 1, 2, 3, 4 from this row. So you should have 20. And then we have 1, 2 from that row, and then 1 in the last row. This is the experimental, not the theoretical. Okay, so your theoretical probability and your experimental probability are going to differ. Okay, so that is my number of evens. So if I know my number, my even numbered ones, how can I just get my odd numbers really quick? Yes. Okay, so I should have 29 tallies for my odd cards then. Okay, so here I have my tallies. As I went through, I just tallied my even numbers. So I should have 29 for my odd cards. Okay, so you should have 23 for even, 29 for odd. So to find my frequency then, I just have to say, well, I had 23 and 29. Okay, then I just have to state the experimental probability. Okay, so the experimental probability is 23 out of 52. And we can just put that into a percent. So take 23 divided by 52, multiply by 100. So that's about 44.2%. Okay. So what was my probability of my theoretical probability of success from step 2? Do you know what it is? My theoretical probability is a 6 out of 13. So I want to compare my theoretical probability and my experimental probability. Okay? So my experimental probability is less than. Okay, so this is less than. The theoretical probability. Make sure I spell this right. Of 6 out of 13, or I got that to be 46.2%. Okay, so at the end you just have to compare the two. So my theoretical probability was greater than my experimental probability. Now sometimes it will happen that your experimental probability is greater than your theoretical probability. So it won't always be less. So with the one I have here, so it did change. I know you're still copying, but on the original one I did, I had 30 even cards, and my experimental probability was 57.7. So I just had to state that that was greater than the theoretical probability of 46%. Okay? So in this one it was less, so we stated it's less than that theoretical probability. Okay, does that make sense? how to conduct that experiment, how to do step by step. Most of these steps we have